Good afternoon, all of you. So today we will discuss problems on DC machines. So wrote down this problem. A 4-pole 500 volts shunt motor has total 720 armature conductors which are wave connected. The full load armature current is 60 amperes and the flux per pole is 0.03 webers. Armature resistance is 0.2 ohms. The voltage drop across the brush is 1 volt. Calculate the full load speed of the motor. Calculate the full load speed of the motor. So we know that back EMF in a motor, EB is given by so this is the back EMF equation of the motor. E equal to pi z by 60 into P by A. From this, we are able to calculate the speed of the motor. So N is there. So we need to calculate speed, full load speed of the motor. Full load speed of the motor. So that means N value we are calculating. So if you want to calculate the speed, you must know the back EMF, flux, Z, poles, 60 and A value. So for that purpose, we first calculate the back EMF, EB value. So here EB is replaced with E only. So E equal to EB back EMF. So this is equal to EB. Equal to EB back EMF. So this is the motor. So motor means terminal voltage is more, V is more. So V equal to EB plus IRA. So EB equal to V minus IRA. Generally, in case of motor, V equal to EB back EMF plus IRA. So in DC motor, in generator, EG equal to IRA. EG equal to V plus IRA. So this is the equation. So from this equation, back EMF EB equal to, so this is the EB value, EB or E equal to V minus IR. So here 500 volts voltage is given, armature current 60 amperes, voltage 500 volts, and resistance is also given, armature resistance 0.2. So 500, so this is 500 minus 60 armature current into resistance, minus the brush voltage drop, This is general formula. Voltage drop across each brush equal to 1 volt. We have 2 brushes. So for 2 brushes, 2 volts. So this is the brush drop. So minus the brush drop value. V minus IARA minus brush drop. That is 486 is the back EMF value, EB value. So that means this value is calculated here. So you substitute in this equation, then calculate the speed. So speed equal to E into 60A by pi ZP. E value 486. 60. So wave connected means, so this is a wave connected. So wave connected means capital A equal to 2. A equal to 2 for wave connection. So then flux value 0.03. Total number of conductors Z value 720. Number of poles 4. 4 poles. Equal to 4. Number of poles 4. 720 armature conductors. So therefore speed equal to 675. Speed equal to 675. So that is the full load speed of the motor at a given value of current. Armature current 60 amperes. So that's why is the speed of the motor at a given value of current. So this is the problem based on DC shunt motor. Once again, I repeat this same problem. So poles 4, voltage 500 volts, total conductors 720, parallel path wave connected, A equal to 2, armature current 60 amperes, flux per flow 0.03 Weber. So in a motor, P equal to EB plus IRA plus brush drop. Plus brush drop. So brush drop is represented to BD plus brush drop PD. So in many cases, brush drop is neglected. Not if brush drop is not given, that is neglected, negligible. So from this E equal to V minus IRA minus brush drop. For 1 volt, for one brush, 1 volt. For 2 brushes, 2 volts. So in this manner, we calculate the speed of the motor. And next problem. So in last problem, the problem is based on shunt motor. So this problem is based on series motor. A series motor has a resistance of 1 ohm between its terminals. The motor runs at 800 RPM at 200 volts, taking a current of 15 amperes. Calculate the speed at which the motor will run when connected in series with 5 ohms resistance and taking the same current at same supply voltage. So resistance of the motor varies. So in series motor, both armature and the series field are connected in series. So the total resistance is given actually, and that means the total resistance of the motor equal to R equal to RA plus R series resistance. It is the field winding resistance. Field and armature both are connected in series. So this is the R value. This is the actually this is the total R value. Total R value in the terminals means the total resistance R value is given. Total resistance R value is given. So 200 volts is the voltage. Case 1, first case. So first case 1. So that's why it is with E. So same voltage means voltage is same. E1 equal to V minus IA RA. IA value 15 amperes. So IA is also same. So that's why IA resistance value 1 ohm in between the terminals. So this is the 1 ohm. So 185 volts is the first voltage. Case 1 volt. For second case, 5 ohms resistance is added in series in series. So that means series model. This is the series winding, armature. So this is the first case. So in between the two terminals, so the total resistance is given. First 1 ohm is the total resistance in between the terminals, these two terminals. So now that 5 ohms resistance is added and taking the same current, same supply voltage. So for RA, and that means we have 1 ohm resistance, we add 5 ohms resistance. So 1 ohm resistance, 5 ohm resistance. So that is E2 value. E2 equal to only voltage is also same, 1 ohms minus total current is also same, 15. Initial resistance 1 ohm, additional resistance 5 ohms. Now the voltage becomes 110 volts. We need to calculate the speed of the motor. So we know that speed is proportional to back EMF. So N2 by N1 equal to E2 by E1. So N2 equal to N1 into E2 by E1. Because current constant means flux is also constant. So flux constant means speed is proportional to back EMF. So this is the formula for calculating the speed of the motor. So we know that speed is proportional to back EMF and flux. Back EMF and flux. So current is constant, that is 15 amperes current is constant. In two cases, same current will flow. So that is 15 amperes current is constant. 15 amperes current constant means flux constant. So flux constant means N is proportional to EB. So N2 is proportional to EB2. N1 is proportional to EB1. So N2 by N1 equal to E2 by E1. So this is nothing but back EMFs. So in the E2 is E1. So that this is the E1 value. E2 and E1. So N2 equal to N1 into E2 by E1. E2 by E1. First case E2 value. So this is also E1 value. So E1 value 185, 110, 800. So 476 RPM is the speed of the motor. So in this manner, I will calculate the speed of the motor at a given value of load, currents. So this problem is based on series motor. Last problem is based on shunt motor. So why flux is constant means motor taking same current in two cases. Motor taking same current. So in series motor, armature current, load current, and field current, all currents are same. Same current will flow because all are current in series. So that's why same current. So same current means flux is constant. So this is the shunt generator. Problem is based on shunt generator. Shunt generator delivers 50 kilowatts. So electrical load. This is the electrical load at 250 volts and 400 RPM. The armature resistance is 0.02 ohms and the field resistance is 50 ohms. Calculate the speed of the machine when running as a shunt motor. Calculate the speed of the machine when running as a shunt motor and taking 50 kilowatts input at 250 watts. First case, machine act as a generator. Second case, machine act as a motor. This is a combination of generator and motor. This problem is the combination of generator and motor. Two cases are combined. So in first case, a generator delivers 50 kilowatts at 250 volts at 400 RPM. Armature resistance and field resistances are given. Calculate the speed of the machine when running as a shunt motor and taking 50 kilowatts input at 250 volts. Voltage is also same, taking power 50 kilowatts. So calculate the speed. We need to calculate the speed of the motor. Speed of the motor. Speed of the motor. So this is the problem. Just note down the problem. Very, very important. Initially, machine act as a generator. So initially, machine act as a generator, which takes power, voltage 250 volts. So armature resistance is given and shunt field resistance is given. So this shunt field resistance is equal to 50 ohms. So this is a 50 ohms resistance. So here source voltage, armature and field, three are connected in parallel. So voltage is same. So if you want to calculate the field current IF or shunt current, field current or shunt current IF. So this IF value equal to this voltage by this resistance. Voltage by resistance. So this is equal to 5 amperes. So this is equal to 5 amperes current, field current or shunt current equal to 5 amperes. Now load current is calculated. So in DC power equal to V into I. So therefore I equal to P by V. So I load current IL equal to P total power by P voltage 250. So that is total load current equal to 200 amperes. That means push. So this is generator case actually. So generator means current delivers. So this is generator case. So generator means current delivers. So current delivers. So this current equal to 200 amperes. 200 amperes. Generator delivers current. So this current field current equal to 5 amperes. So this total current equal to 205. Generator delivers 205, 200 plus 5, 205 amperes of current from the armature. So this is armature current. Armature current equal to 200 plus 5, 205 amperes of current. So therefore generated EMF equal to voltage into IRA. Bus stop is not given. Bus stop is not given. Bus stop is neglected. So generated EMF equal to terminal voltage plus drop. Terminal voltage 250. IAR, IA value 205, resistance value given 0.02. So this is total generated EMF. This one is the total generated 254.1. So for same load, in case of motor, it is a motor back EMF. To calculate the back EMF. So back EMF equal V minus IRA. Brush drop is not given. Brush drop is neglected. So V minus IR. So here also IL value, load current value is same 200. So in case of motor takes 200 amperes of current. From this 200 amperes, I will draw a circuit for motor. So this is armature, shunt field, motor. So for same load means in case of motor, same 250 volts. Motor takes 200 amperes. So 200 amperes current, motor takes 200 amperes of current. So from this 200 amperes, the shunt field current is constant in both cases. Direction and magnitude is constant in both cases, generator as well as motor. So from this 200 amperes, shunt field takes 5 amperes. So therefore armature current equal to 195 amperes only. 195 amperes only. Voltage, load, all parameters are constant. So this is the 250 volts. Voltage is 250. Voltage same. Voltage same. So armature current changes from 205 to 195 because the shunt field current is constant in both cases. Load current is also constant. Therefore armature current changes. So in this case, armature current equal to 195 amperes in motor case. So this is the motor. 195 amperes. So IA equal to IL minus IF. So IL 200 minus 5 amperes, 195 amperes, IA value. So in case of motor, back EMF equal to V value same, armature current resistance 246. 246 is the back EMF. So therefore motor speed by generated speed equal to motor back EMF by generated EMF. So motor speed equal to, in this manner, motor speed is calculated. So here we have generator and motor, same problem for generator and motor. So in generator case, generator delivers current. Generator case, generator delivers current. So shunt generator delivers 50 kilowatts. So this is the power. Power means voltage into current at 250 volts and 400 RPM. The armature resistance and field resistance is same in two cases. Voltage, power is also same. Voltage is also same. Calculate the speed of the machine when running as a shunt motor and taking 50 kilowatts. Input voltage 250. Motor speed calculation. Calculate the motor speed. Motor speed. You need to calculate the motor speed. So first of all, so load current equal to total power by voltage. Load current equal to power, total power by voltage. So this is 200 amperes. This generator delivers 200 amperes of current. So shunt field current equal to 250 by 50, 5 amperes. So from this we take 5 amperes. So we 5 amperes field current, 200 amperes load current. So that means this armature total current incoming to this node equal to outgoing currents. So outgoing currents are 5 amperes to 200 amperes. So 200 plus 5 amperes, 205 amperes. So generator delivers 205 amperes of current. So therefore armature current equal to 205 amperes. So generate EMF equal to voltage plus IARA drop. Voltage 250 plus IARA. IA value 205 to resistance 254.1. Now in case of motor, motor takes power, generator delivers power. So motor takes power means same 200 amperes of current takes, because load current equal to power by voltage, power same current. So that means motor takes 200 amperes of current. So the shunt field current direction is same for in two cases. So it may be a generator or it may be a motor. Shunt field current direction is same. So shunt field current direction is same means from this 200 amperes, the shunt takes 5 amperes. So the remaining current 195 amperes taken by the armature. So the armature current equal to 195 in case of motor. So V minus IA RE 246 amperes. We know that shunt field current is same in two cases. So that means flux is constant. We know that back EMF equal to in generator or motor or EG equal to pi Z by 60 into P by A. So that means speed equal to speed. In last case also I tell here, speed is proportional to voltage by flux. Speed is proportional to voltage by flux. Shunt field current is constant in two cases, that is 5 amperes. So that means flux is also constant. Flux constant means speed is proportional to voltage, back EMF or generate EMF. So speed is proportional to back EMF or generate EMF. N generator is proportional to E generator. N speed of motor is proportional to back EMF, EM. So therefore Nm by Ng equal to Em by Eg. So in this way we calculate the speed of the motor. Okay. So next one. Note down this problem. The resistance of the armature circuit. The resistance of the armature circuit of a 250 volts DC shunt motor is 0.3 ohms and its full load speed is 1000 rpm. Armature resistance of the circuit, voltage 250, resistance 0.3 ohms, full load speed 1000 rpm. Calculate the resistance required in series. Calculate the resistance required in series with the armature to reduce the speed with full load torque to 800 rpm. 800 rpm. The full load armature current being 50 amperes. So full load armature current 50 amperes. The load torque is then halved. Halved means halved. At what speed will the motor run? The armature reaction effect is to be neglected. So this is the problem and the problem. First of all, read the problem carefully. The resistance of the armature circuit of a 250 volts DC shunt motor is 0.3 and its full load speed is 1000 rpm. Calculate the resistance required in series with the armature circuit to reduce the speed with the full load torque to 800 rpm. So that means speed, you need to reduce the speed of the motor from 1000 rpm to 800 rpm. And the full load armature current being 50 amperes. The load torque is then half. At what speed will the motor run? The armature reaction effect is neglected. So typical and lengthy problem. So first to calculate the back EMF. So back EMF equal to V minus IRA. Press drop is not given. So press drop is not given means press drop is neglected. Voltage 250, armature current 50 amperes, resistance value 0.3. So 235 volts is the back EMF. So we know that back EMF equals some constant K into pi n. The speed is proportional to back EMF EB by 5 or EB equal to we know the general formula EB equal to pi z by 60 into P by E. EB equal to pi Z N by 60 into P by E into P by E. So from this P by A constant, 60 constant, Z constant. EB is proportional to flux and speed. So this is the equation. EB is proportional. So EB or E is proportional to flux and speed. This is the constant. All are represented with the constant. E equal to K into phi N. So voltage we know 235 back EMF. K flux speed 1000 rpm. So from this K phi equal to 235 is value. So if you need to calculate the E value at 800 rpm because speed is reduced from 1000 rpm to 800 rpm. So here we calculate at 1000 rpm. Now we calculate E at 800 rpm. So this is the E value at 800 rpm. E value at 800 rpm. Flux is constant. That is 0.235 800 rpm. So this is the E value at 800 rpm, 188. Like an extra resistance R is put in series with the armature circuit because if you want to change the, you want to reduce the speed, the series resistance is added in series with the armature circuit. I will draw here circuit diagram. So this is the shunt motor. Actual shunt motor. This is the shunt motor. So this is the shunt motor. So if you want to reduce the speed of the shunt motor, a series resistance is added. So a resistance is added in series with the armature. If you want to increase the speed, we add the resistance in series with the field. If you want to reduce the speed, you add this resistance in series with the armature. So to want to decrease the speed, the resistance is added in series with the armature, extra resistance. So this value of resistance is added in series with the armature. So this is the R value. R is added. RA. So this is the extra resistance is added to reduce the speed of the motor. So we know that E equal to this value. Same formula, back EMF equal to V minus IRA. So same formula, E equal to V minus IA RA. Total resistance of the circuit, RA plus R. External resistance. This is the R is called external resistance. Extra resistance or external resistance R. So calculate the R value. So this is the R value. This much of resistance is inserted in series with the armature. Then the speed becomes 800 rpm. Then the speed becomes 800 rpm. The load torque is halved. Load torque is halved means if load torque is halved means A is halved. How torque half? Torque becomes half. IA is also becomes half because torque is proportional to. So we know that torque is proportional to flux into armature current. Torque is proportional to flux into armature current. So this armature torque is proportional to flux into armature current. So this is a shunt motor. Shunt motor means flux remains constant. Flux does not change because here flux is not changing. So flux constant is torque is proportional to armature torque is proportional to IA. Armature torque is proportional to IA. So armature torque half means armature current is also half. Since there is a linear relation between the torque and the armature current in the shunt motor. The shunt motor relation between the torque and the armature current is linear. So therefore, IA equal to 25 amperes. IA equal to 25 amperes because initial current equal to 50 amperes. So So torque half means armature current is also half. So initial current equal to 50 amperes. See this. Here armature current equal to 50 amperes. Here the armature current equal to 25 amperes. Why? Because torque half means armature current also half, because torque is proportional to armature current in shunt machines. So in this manner we calculate the E1 value. So for this we calculate the E1 value. So therefore E same, EB is proportional to N, EB is proportional to N. So EB is proportional to N means E1 is proportional to N1, EB is proportional to N2. Or E is proportional to N, E1 is proportional to N1. Therefore, speed of the machine is calculated. Speed of the machine is calculated. So lengthy problem, important. If you want to reduce the speed of the motor, the resistance of the series connected in series with the armature. If you want to increase the problem, increase the speed, resistance is added in series with the shunt field. Here we add the resistance in series winding. Want to increase the speed, resistance is added in series with the field winding. In a shunt motor, torque is proportional to armature current. In a series motor, torque is proportional to Ia square. Series motor means torque is proportional to Ia square, because flux is proportional to armature current in series motor. So flux is proportional to armature current means so torque is proportional to phi Ia, flux is proportional to Ia. So torque is proportional to Ia square in series motor. So this is a shunt motor. Shunt motor means flux is constant. So torque is proportional to armature current only. Torque is proportional to armature current. So this is the basic formula for torque. Torque is proportional to flux Ia. So flux is proportional to constant. The series motor, flux is proportional to armature current. Flux is proportional to armature current. Therefore, torque is proportional to Ia square. So in series motor, torque is proportional to Ia square. In shunt motor, torque is proportional to in shunt motor, torque is proportional to Ia only, because flux is constant. Ia only because flux is constant. Ia square. Shunt motor, series motor. Remember. Next one, series motor. A 220 volts DC series motor is running at a speed of 800 rpm and draws 100 amperes. Calculate at what speed the motor will run when developing half the torque. Total resistance of the armature and field is 0.1. Total resistance. That means armature resistance and the shunt field resistance. Remember, in case of shunt motor, shunt field resistance is very high. That is around 100 ohms, 200 ohms like that. Armature resistance is very small. That is around 1 ohm. But in case of series motor, armature resistance is also very small, because in series motor, armature and field both are connected in series. Load current also passes through field winding and armature winding. So that's why resistance must be very small in series motor. So here see there is. So the resistance in armature resistance is also very small. Armature resistance is also very small. See here the series motor armature resistance is 0.1, both armature and shunt field is 0.1 total resistance. Assume the magnetic circuit is unsaturated. This point is also very important in series motor problem. So unsaturated base. So we know that torque is proportional to flux and armature current. Basic formula, flux and armature current. So unsaturation means this flux is proportional to armature current. So this flux is proportional to armature current. Therefore, torque is proportional to Ia square. Torque is proportional to Ia square if unsaturated. Magnetic circuit unsaturated means torque is proportional to Ia square. If magnetic circuit is saturated, torque is proportional to Ia only. Torque is proportional to Ia only if magnetic circuit is saturated. Magnetic circuit is saturated, torque is proportional to Ia. Unsaturated, torque is proportional to Ia square. So saturation means flux. This flux, unsaturation means flux depends upon armature current. Saturation means flux does not depend upon armature current. So that's why. So this is the unsaturation. First case one, unsaturation. So case two, saturation. Saturation means flux does not change. So T is proportional to Ia. Unsaturation means flux depends upon Ia. So torque is proportional to Ia square. So for series motor, here I explain here same. So for series motor, flux is proportional to armature current, torque is proportional to Ia, therefore torque is proportional to Ia square. So torque is proportional to Ia square, T1 is proportional to Ia1 square, T2 is proportional to Ia2 square. So T2 by T1 equal to Ia2 by Ia2. Ia2 by Ia1. So therefore here Ia2 is calculated. In the given data, Ia2 is calculated. Armature current. Same, back EMF equal to V minus Ia, RA is same. So case 1, Ia1, voltage is same, two cases. Back EMF 1 equal to V minus Ia1, RA. Armature resistance is also same in two cases. So this 210 volts, E2, V minus Ia2, RA, 212. So here, N is proportional to back EMF by flux. Back EMF by flux. So therefore N1 by N1 is proportional to E1 by 5. N2 is proportional to E2 by 5. So first case N1 is proportional to E1 by 5. Same, N2 is proportional to E2 by 5. So we need to calculate N2 value. That means equation, suppose this is the equation 1, equation 2, second equation. E2 equation 2 by equation 1, N2 by N1 equal to E2 by E1 into 5 1 by 5. 5 1 by 5. 5 1 by 5. So flux is proportional to armature current. Flux is replaced with the armature current because unsaturation. So 5 1 by 5 2 means Ia1 by Ia2. Then speed of the motor is calculated. Speed of the motor is calculated in this way. I think you understand the problem. You have any doubts? Any doubts? So I repeat the same problem. A 220 volts DC series motor is running at a speed of 800 rpm. Initial speed is given N1 value. This is N1 value. And draws 100 amperes. It's the Ia1 value. Calculate at what speed the motor will run when developing half half the torque. Torque is half. T1, for example, first one is T1. In second case, T1 by 2. Torque becomes half. T2 equal to T1 by 2. T2 equal to T1 by 2. So torque becomes half. Torque becomes half. Total resistance of the armature and field is 0.1. Armature resistance is given. Assume the magnetic circuit is unsaturated. Magnetic circuit is unsaturated. So for series motor, flux is proportional to armature current because in series motor both are connected in series. So in series motor, so suppose this is the field. So this is the armature. So both armature and field both are connected in series motor. So given voltage 220 volts. 220 volts is the given supply voltage. Total resistance means series resistance plus armature resistance RA plus RS. RA plus RS. Total resistance RA plus RS equal to 0.1. Assume that magnetic circuit is unsaturated. Magnetic circuit is unsaturated means flux is proportional to armature current. If magnetic circuit is saturated, flux does not depend upon armature current. Flux is constant. So IA value increases, flux is constant. If IA value decreases, flux is constant. That means flux does not depend upon armature current, that is saturation. Flux depends upon armature current, unsaturation. So it is, we know that torque is proportional to flux and armature current. So flux is proportional to armature current, therefore torque is proportional to IA square. So T1 is proportional to IA1 square, T2 is proportional to IA2 square. So T2 equal to half of the torque, T2 equal to T1 by 2 by T. So this value, T2 equal to T1 by 2. The torque half, torque second, T2, torque half, and develop half the torque. So that's why T2 is replaced with half into T1 value. So then from this we calculate the IA2 value, that is 70.7. Then calculate the E1 and E2 value. We know that speed is proportional to back EMF by flux. Same back EMF formula. EB equal to pi Z by 16 to P by A. EB equal to pi Z by 16 to P by A. From that, N is proportional to EB by flux. N1 is proportional to E1 by phi1. N2 is proportional to E2 by, sorry, phi2. So N2 by N1 equal to E2 by E1 into phi1 by phi2. So phi1 by phi2 is replaced here. Phi1 by phi2 is replaced with I1 by I2 because in the series motor flux is proportional to armature. In this manner we calculate the speed of the motor. If you have any doubts? Thank you. We will meet our next class with same problems.